to speak about a little bit about Decerna. So, Decerna is a consultancy which works to facilitate the transition towards a low carbon economy powered by clean, affordable energy. We do this through our four key service areas, which are smart home technology field trials, grid scale renewables and energy storage, energy efficiency renewables and storage in the built environment, and a life cycle assessment and net zero carbon reduction plans. We do all of this alongside developing our own solar energy storage and grid stability assets. And so, what is this workshop and who is it for? So, this workshop is meant to provide a foundation on the fundamentals of base year assessment and target setting, which are the essential first steps for businesses who are both starting their journey towards net zero and those who have already committed and need some guidance. So, what are the aims for this presentation? It's firstly to show the importance of net zero and what it means for a business, discuss the different steps involved in completing the base year assessment, and to provide guidance on how to calculate greenhouse gas emissions and set reduction targets that are aligned with the GHG protocol and Science Based Targets Initiative, and to also highlight development of emission reduction plan, which will be further explored in one of our other workshops that we offer. So a bit about this presentation. So this presentation will be for about 60 minutes. And if you have any questions, please use the Q&A feature and they will be answered in between different sections of the workshops. The slides will be sent over by email after this presentation. And I would also like to inform that there will be some overlap with our other workshops that we offer, which I will let you know when we come to those. So, moving to the next slide, which is why is achieving net zero emissions important and how are the greenhouse gas emissions related to it? So, we all know that the global temperatures are increasing year after year, and the greenhouse gas emissions are directly linked to the increase in the global temperatures. So, the UN Climate Change Conference happened in Paris in 2015, in which 196 parties came together and adopted the Paris Agreement, which is a legally binding international treaty on climate change. And its goal is to limit the temperature increase to 1.5 degrees Celsius above the pre industrial levels. And failing to limit our global temperatures to 1.5 degrees Celsius will dramatically increase the chances of extreme flooding, drought, wildfires, and food shortages. Global warming is proportional to the greenhouse gas emissions, which means that the planet will keep heating for as long as the global emissions exist. Hence, the greenhouse gas emissions must decline by at least 43% by 2030, and which in turn will help the global emissions reach net zero by mid of the century in order to be aligned with the Paris Agreement. So, what does net zero mean? Net zero is achieving a balance between greenhouse gas emissions produced and removed from the atmosphere. To achieve this balance, by middle of the century, the world must reduce emissions to as close to zero as possible, with any remaining emissions absorbed through natural sinks, carbon sinks like forests, and new technologies like carbon capture. And if we are successful in achieving the global emissions of greenhouse Achieving this, then the global emissions of greenhouse gases will be net zero. A business is said to have achieved net zero if it has reduced its scope 1, scope 2, and scope 3 emissions following science based pathways, with any residual greenhouse gas emissions being fully neutralized by permanent or like for like removals exclusively claimed by that organization. So, a business might start their journey towards net zero for the following reasons, like cost reduction, increased social responsibility, which in turn increases the reputation of the business, improved operational efficiency, staying ahead of regulations, and employee retention and attraction. So, these are the key drivers for a business to start their net zero journey. And many of you might ask, where do we as a business start our net zero journey? The journey actually starts from the thought, a desire to do something about it. And that's why you're all here. So, with that positive note, we can now move on to discuss the journey, and we will help you to reach your help you in your journey until you reach net zero. So the infographic shown gives an idea of what a business's journey to net zero looks like. The first two steps, which are base year assessment and commitment and target setting, can be interchanged in their order. So some businesses might prefer to complete their base year assessment first and then commit to net zero and set their targets. And some businesses might prefer to commit to net zero and set their targets before their base year assessment. So it totally depends on each business to choose what they would like to go about. And these two steps are then followed by creating an emission reduction plan and the rest of the other steps. So, the journey as a whole is discussed in more detail in our Net Zero Journey for Businesses workshop. Here, we will mainly focus on base year assessment, commitment, and target setting, and briefly on creating an emission reduction plan. As far as emissions calculation, reporting, and target setting are considered, there are two main bodies that have set standards and frameworks that are widely used across the globe. So they are the Greenhouse Gas Protocol, commonly referred to as the GHG Protocol, and the Science Based Targets Initiative, referred to as the SBTI. So the Greenhouse Gas Protocol provides comprehensive guidelines and tools for organizations to measure, report, and manage their greenhouse gas emissions. It offers a consistent and transparent framework for tracking emissions from various sources, including direct emissions from owned or controlled sources, indirect emissions from purchased energy, and other indirect emissions from the value chain. And the Science Based Targets Initiative, which is SBTI, helps companies set ambitious and science based greenhouse gas emission reduction targets in line with the goals of the Paris Agreement and with the amount of carbon budget left. So, science based targets show companies how much and how quickly they need to reduce their greenhouse gas emissions to prevent the worst effects of climate change. For now, in this workshop, we will be exploring the initial steps a bit more in detail. And for this, we will be traveling along with a company called Magnus Carbonis, shortly called MC Manufacturing. So, Magnus Carbonis Manufacturing is a mid sized manufacturing company focused on producing consumer goods. They are committed to reducing their environmental impact by understanding their emissions and begin their journey towards net zero. So let's say they have three different operating units, alpha, beta, and gamma, to handle the different stages of production and distribution. So alpha consists of a manufacturing unit, warehouse, and an office. Beta consists of a packaging unit and a warehouse. And gamma has a warehouse and handles the distribution of the finished goods. So throughout this webinar, we'll see how MC manufacturing are accounting for their emissions from the three operations and setting their targets. So now discuss in detail the initial steps involved in the business's journey to net zero and how MC Manufacturing goes about each step. So we will now move on to the first step in our journey, which is the base year assessment. So, what is base year assessment and why is it important? So, an emissions baseline or a base year assessment refers to the greenhouse gas emissions your company emitted before you started taking steps to reduce your emissions. This will be your starting point on your way to reaching net zero. And by doing this, you can better understand which areas of your business are producing the most emissions, and therefore which areas you can target in order to make the best impact on your emissions. And having your base year assessment completed provides a great reference point for you to measure your reductions over time, allowing you to understand the impact you are making. So, based on the Greenhouse Gas Protocol's corporate standard, base year assessment involves a list of steps. Setting boundaries is the initial step in a base year assessment. Boundaries are imaginary lines that encompass the emissions to include in a company's GHG inventory. And in the base year assessment, we will be discussing two main types of inventory boundaries. One is organizational boundary, and the next one is operational boundary. So, once the boundaries are defined, the next step involves choosing a base year, followed by creating base year inventory, and then calculating base year emissions. So, the first step, which is setting organizational boundaries. So, this determines which company operations to include and what fraction of emissions from those operations should be included. So, importance of organizational boundaries comes into picture for complex structures. For example, many companies consist of subsidiaries, joint ventures, and franchises. So, setting organizational boundaries will establish a consistent method for calculating emissions from all the components of an organization. The more complex the company structure is, the more important it is to set organizational boundaries. So the GHG protocol recommends using consolidation approach, which is combining emissions data from separate operations. So within the consolidation approach, there are two types, which is equity share approach and the control approach. So under equity share approach, emissions are calculated based on equity share a company holds in each operation, regardless of who controls the operation. For example, if a company owns 50% share in two of the operations, and if they choose to report emissions using the equity share approach, then the overall emissions for the operations will first be calculated, and then 50% of the emissions of the operations will be taken into account to consolidate for the company's total emissions. So, under control approach, a company can choose to calculate their emissions based on financial control or operational control. So, financial control is the ability to direct an operation's financial and operating policies to gain economic benefits from its activities. And operational control is the authority to introduce and implement operating policies. So, if a company chooses to calculate its emissions based on operational or financial control, 100% of the emissions from operations under company's financial or operational control are considered for consolidation. And in special cases, some companies may hold a joint financial control. In those cases, emissions will be considered based on the percentage of financial control that company holds in its operations. So MC Manufacturing has three operations: alpha, beta, and gamma. The company has equity share of 100% on alpha and 100% on beta and 50% on gamma. And MC Manufacturing has no financial control over alpha and beta, but has financial control on gamma. And MC Manufacturing has full operational control on alpha, but none on beta and gamma. So if you consider alpha, beta, and gamma have each calculated their emissions, and if MC Manufacturing uses the equity share approach, it will account for 100% of emissions from alpha, 100% of emissions from beta, and 50% from gamma. Or if MC Manufacturing uses financial control approach, it will account for zero emissions from alpha and beta and 100% from gamma. And if MC Manufacturing uses the operational control approach, then it will account for 100% of emissions from alpha but none from beta or gamma. So most commonly businesses go with the operational control approach. So let's assume the same in this case. So let's assume that that MC Manufacturing have decided to go with the operational control approach. Hence, they will account for 100% of emissions from alpha and none from beta and gamma. So once the organizational boundaries are defined and we now know which parts of the corporate structure should be included in the inventory, then the next step is setting the operational boundaries. So operational boundaries determine which of those specific emission sources associated with those operations are to be included. Operational boundaries also determine how the emission sources must be categorized. In order to define the operational boundaries, companies must first identify the emissions associated with their operations. The company must then classify their emissions as direct or indirect. And the final step under this would be to categorize the scope of emissions. So, according to the gas protocol, emission sources are classified into scopes 1, 2, and 3. So, let's see what each scope includes. So, scope 1, which is also called direct emissions, are emissions from activities and sources owned and controlled by the business. Everything falls under scope 1. So, scope 1 emissions are what you burn. So that will be your gas or oil burning boilers, non-electric vehicles that are owned by the company, any leaks from refrigeration and air conditioning units, and process emissions from factory fumes and chemicals. And scope 2, so these are emissions associated with consumption of purchased electricity, heat, and steam. These emissions result from your use of energy but are emitted somewhere else, which isn't under your direct control. So, most commonly, you'll find an SME scope to emissions are solely from electricity, unless you happen to be on a district heat network. Because scope to emissions are primarily electricity, this means that as the UK grid decarbonizes, the impact of scope to emissions will also reduce for businesses. And with regards to scope 3, so scope 3 is for emissions which an organization is indirectly responsible for. So, this is commonly the largest part of an organization's carbon footprint. And examples of scope 3 include business travel, employee commuting, and emissions related to production of purchased goods and services, as well as investments and waste disposal. So, scope 3 is a very broad area, and there are a lot of different categories involved in this which can contribute to a large proportion of a company's greenhouse gas emissions. So, with regards to operational boundaries, MC Manufacturing have identified their emission sources. So, just a small exercise for you all. So, can you help MC Manufacturing categorize their emissions into different scopes? So, you will receive the questions in the polls. Um, So, which scope does the gas used in a boiler on site fall under? If you can give your choice of. So, gas use in a boiler on site falls under scope 1. Which under which scope does purchased goods and services fall under? So, purchased goods and services falls under scope 3. So the next one, refrigerant leaks. So under which scope would we calculate the refrigerant leaks? So the refrigerant leaks would come under scope 1. And the next one is business travel. So business travel falls under indirect emissions, and that would come under scope 3. And the last one, electric vehicles owned by MC Manufacturing. So which one would they fall under? So emissions from the company owned electric vehicles would fall under scope 2 because uh, they consume electricity and not any fuel. So all the electric vehicles would come under scope 2. So thank you for your responses. I think that's missed in the table. So which scope would waste generated in operations fall under? I apologize. The waste generated is not there in this table, but the waste generated would fall under scope 3 as well. Thank you for your responses. So moving on to the next slide. So setting operational boundaries is all about identifying emission sources related to the included operations and categorizing them into different scopes as shown here. So moving on to the next step within the base year assessment. So once the organizational and operational boundaries are identified, the next step is to choose a base year. So base year is the period in history against which a business's emissions are tracked over time. Once the emission sources are identified and categorized, the activity data must be collected for the identified emission sources. And this may include energy consumption, fuel usage, employee commute miles, business miles, spend data on purchased goods, etc. And based on the data collected, businesses can choose the earliest relevant point in time for which they have reliable data. And base year can be any given period, but for businesses it is highly recommended to either have the calendar year or their financial year as the base year period. And once the base year period is fixed to either calendar year or financial year, businesses must use the same period for rest of their reporting years to be consistent in their reporting. So again, example with MC Manufacturing. So MC Manufacturing have collected data on their emission sources. They find that they have only scope 2 data for 2018 and for scope 1 and scope 2 emissions data for 2019, but there's no sufficient scope 3 data. And from 2020 onwards, they have data for all three scopes. So according to you, which year would you think MC Manufacturing should choose as their base year? So the option one is to choose 2020 as their base year to include all three scopes. And option two is to choose 2019 as their base year for scope one and two, and choose 2020 as their base year for scope three. And option three is choosing either option one or two. So the right answer is they can choose either option one or two. So it's okay to choose. I mean, it's okay to have the same base year for all three scopes or a different base year for scope three alone. So they can choose any of the two options. And in this case, so let's assume that MC Manufacturing have chosen option one, which is 2020 to be their base year for all three scopes. So moving on to the next step within the base year assessment is creating the base year inventory. So once the base year is chosen, the next step in the base year assessment is to create the base year inventory. And as MC Manufacturing have chosen the operational control approach, they will only account for emissions from alpha and not from beta or gamma, as they do not have any operational control on beta and gamma. And MC Manufacturing will now collect activity data for different emission sources for the chosen base year 2020 and then calculate their base year emissions for their unit alpha. So, to be able to complete a base year assessment, businesses must first collect data which will help them calculate their greenhouse gas emissions. And with regards to alpha, so alpha consists of a manufacturing unit, a warehouse, and an office. So they mainly use electricity for their manufacturing processes and for heating their office. And they have company owned delivery and passenger vehicles and EV vans for delivery. And also, they have a record of data for purchase goods services, employee commute, business travel, and also waste generated in operations. So this will be alpha's base year inventory. And until this, do we have any questions from any of you, please? You can use the Q&A feature to ask your questions if you've got any.
And you can also use the chat now. So you can use chat for your questions.
Okay. So, if we've not got any, uh, I can't.
We've got a question being typed. If you want to just give us a few
Oh,
more
okay, sure.
seconds.
Yeah.
There you go.
So, how do Decerna decide the cost for large range or data which has to go? So it will, the cost with regards to producing an emission report will totally depend on where the SME is. So, for example, for an SME within the Tees Valley region, we have the Net Zero Tees Valley project. So, within that, I think producing an emission report is free of cost. So we are now in the process of launching our own tool, which will help businesses calculate their emissions. So I think for businesses within Tees Valley region, the emissions producing an emission report is free of cost. Any other questions?
Mhm.
So if you've not got any questions, we'll move on to the next section of the workshop. So the next section in the workshop is base year in the base year assessment is the emissions calculation. So scope 1, 2, and 3 emissions are calculated using activity data and emissions factor as follows. So activity data refers to Activity data refers to the amount of fuel purchased, miles traveled in company vehicles, annual electricity consumption cost of purchase goods and services, etc. And this activity data is multiplied with relevant emission conversion factors. And emission factor or emission conversion factors are values used to convert the activity data, such as electricity consumption, to greenhouse gas emissions. So, emission conversion factors represent the average emissions intensity associated with a specific activity or fuel type. The emission conversion factors are measured in carbon dioxide equivalent, which measures the warming potential of different greenhouse gases by expressing their impact as how much carbon dioxide would produce the same warming effect over a specific period. UK government publishes updated values each year to ensure the accuracy of emissions calculation and to allow values reflect changes to emission sources such as the decarbonization of grid. So this is a link for the latest database that the government produced for these emission conversion factors. For scope 1 and 2 and some categories of scope 3, we use the UK government's emission conversion factors to calculate the emissions. And for other scope 3 categories, we will use different set of emission factors, which will be discussed later in this workshop. So just to show how the emission factors can be used to calculate the emissions. The emission conversion factors are relatively easy to use. So, just a small example to show how we are able to use them. So, for example, just consider MC Manufacturing have determined that they use 32,456 kilowatt hours of electricity annually, and they would like to calculate the greenhouse gas emissions produced from this to help with the scope 2 emissions calculation. So the first step would be to open the UK government's emission conversion factors database, choose the grid electricity, and then locate the total carbon dioxide emissions equivalent per unit. So our conversion factor in this example will be 0.19338 kilograms of carbon dioxide per unit, which when is multiplied with the activity data will give us a total emissions for the grid electricity, and that comes up to 6,276.3 kilograms of carbon dioxide equivalent. So, this, when converted to tons, it gives us a result of 6.2 tons of carbon dioxide equivalent annually for the grid electricity consumption. So, with regards to calculation of scope 1, so we will now see how MC Manufacturing calculate their scope 1, 2, and 3 emissions for their unit alpha. So, unit alpha uses gas for space heating of their warehouse. They were able to obtain 1 year's worth of gas bills, which sums up to 205,324.67 kilowatt hours of natural gas per year. So this is multiplied with the emission factor, which is 0.18387. This is obtained from the UK government's conversion factor sheet. So the annual consumption figure is multiplied with the emission factor to obtain the total emissions, which is 37,753.05 kilograms of carbon dioxide equivalent. So similarly, Alpha also uses air-to-air heat pumps to heat their office space. So the air-to-air heat pump contains 12 kilograms of HFC-23 refrigerant and has an annual leakage of 5%. So that results in a leakage of zero point 0.6 kilograms of HFC-23 per year. So this is again multiplied with the respective emission factor for HFC-23 that's obtained from the UK government's conversion factor sheet, and that sums up to 8,880 kilograms of carbon dioxide equivalent. So similarly, the total miles traveled by the company owned diesel vans and petrol cars are obtained from their annual mileage reports and multiplied with the respective emission factors to obtain the total emissions figure for the company owned diesel vans and petrol cars. So moving on to scope 2 emissions calculation. So, scope 2 emissions, as we discussed earlier, are emissions associated with consumption of purchased electricity, heat, and steam. So, emissions from purchased electricity can be calculated using two methods. One is the location based method, and the other one is the market based method. So, location based method reflects the average emissions intensity of grids on which the energy consumption occurs, and market based emissions reflects the emissions from electricity that companies have purposefully chosen. So, for example, to calculate the emissions from purchased electricity in the UK, location based method will use the average grid emission factors published by the UK government, and the market based method will use the fuel emission factors provided by the fuel suppliers. So, if a company operates in a country that provides renewable products, then it must calculate scope 2 emissions in both approaches, even if the business has not purchased any renewable products. So, if the business does not have any renewable products, and it would not have any supplier specific emission factors, then the residual mix emission factor or the grid average emission factor should be used to calculate under the market based approach. And they have to calculate both using location based and market based approach, but the company can choose which among the two must be included to the emissions total. So a company can choose to add the location based emissions or the market based emissions into their emissions total based on the total quantity of emissions. And if they've purchased any renewable products, it would be beneficial to use the market based emissions into the total. And considering MC manufacturing, so Alpha unit mainly uses electricity for their manufacturing processes and heating for the office using air-to-air heat pumps. So they have calculated that their annual electricity consumption is 595,676.0 kilowatt hours of electricity. So to calculate the location based emissions, this annual consumption figure is multiplied with the grid average emission factors for 2020. And MC manufacturing are not on any renewable energy contract, so the fuel mix factor from their supplier has been used to calculate their market based emissions. So if you see here, the location based emissions are more than the market based emissions. So MC manufacturing can now choose which among the two must be included to their emissions total. And here we'll consider that MC manufacturing has chosen their market based emissions to be added to their total. And MC Manufacturing also have two electric vans. So the total miles traveled by the two electric delivery vans are multiplied with the relevant emission factor, again obtained from the UK government's emission conversion factors database, and its total emissions are calculated as 2.799.78 kilograms of carbon dioxide equivalent. So now moving on to scope 3. So, as mentioned earlier, scope 3 is for the emissions which an organization is indirectly responsible for. So, the greenhouse gas protocol classifies scope 3 into 15 different categories as shown in the slides here. But unlike scope 1 and scope 2, a business will have to report emissions only for scope 3 categories that are applicable to them. So, for example, if a company will not report under category 8, which is upstream leased assets, if it does not operate on a leased building. So, a company will have to choose the scope 3 categories that is applicable to their own business operations and then report their emissions based on the categories. So we'll now briefly discuss on the calculation of scope 3 emissions. So calculating scope 3 emissions can become difficult because it involves data from various other businesses within the value chain. So to ease the calculations involved within the scope 3 emissions, the GHG protocol recommends various calculation methods based on the following criteria. So, based on the relative size of the emissions from the scope 3 activity, the company's business goals, the data that's available with the business, the quality of data that's available, the cost and effort required to apply each method, and any other criteria identified by the company. So, based on these various criteria, a company can choose the calculation methodology for each of the scope 3 categories. So each category under scope 3 has specific calculation methods. Some of the calculation methods that are common across some categories are listed here. So some methods like the supplier specific method or average data method, spend based method, distance based method, asset specific method, etc. Some of the common methods within all three scope 3 categories, and different calculation methods recommended under each category are detailed in the greenhouse gas protocols scope 3 calculation guidance, and the link is provided here if you want to learn further on the various calculation methods under different scope 3 categories. So, just for an example, so if a company purchases a manufacturing equipment, it will account for the emissions from the equipment under category 2 capital goods. So, this calculation can be done using any of the four methods that are suggested in the greenhouse gas protocol, such as supplier specific method, hybrid or allocation method, average data method, or spend based method. So, among these four methods, the most accurate method to be used is the supplier specific method, where the supplier of that particular equipment will provide the cradle to gate emissions involved with that particular equipment. And the least accurate method to be used is a spend based method, where the business can use the total amount spent on that particular equipment multiplied with the spend based emission factors that is common for any manufacturing equipment. The spend based emission factors, again, they are not the most accurate ones because they involve a whole set of manufacturing or IT equipment, etc. They are not for any specific equipment as such, so they can be the least accurate method to be used. And but spend based using spend based method can be a good starting point for any company to know where most of the emissions come from. So if you've not got any of the supplier specific or any average data, then spend based method is definitely a very good starting point for you to know where most of your scope 3 emissions are from. With regards to MC manufacturing, we'll now see how they calculate their scope 3 emissions. So MC Manufacturing have purchased a large quantity of raw materials. Their supplier has calculated their own emissions and have allocated emissions for their raw materials. So each item purchased has an emissions of 0.00112 kilograms of carbon dioxide equivalent, which sums to 5.4 kilograms of carbon dioxide equivalent for 4,500 items of raw material that's purchased. And their other significant purchases include IT services and paper products, which also include the packaging material, but then they do not have any specific emission factors for the purchased goods and services, so they use their spend based method to calculate the emissions using their spend data. So they've spent around 9,000 pounds on IT equipment, so this amount spent is multiplied with 0.1314, which is the spend based emission factor for IT equipment. So that sums up to 1182.6 kilograms of carbon dioxide equivalent for any IT equipment that's purchased by MC Manufacturing. Similarly, they've purchased paper and paper products for 13,500 pounds. So this amount is multiplied with 0.707, which is again a spend based emission factor, and that results with 9,544.5 kilograms of carbon dioxide equivalent for their paper and paper products that they've purchased. So, and moving on to next one. So, waste generated in operations include uh, water supplied and disposed, and also waste disposed. So, MC Manufacturing have the data for the water supplied into their premises. So, quantity of water disposed is mostly assumed to be same as the water supplied, and they also have the data on quantity of specific types of waste generated and the disposal method used for the specific waste types. emissions. So the specific emission factors relevant to the waste category and disposal method are obtained from the UK government's conversion factor sheet and is multiplied with the quantity in order to obtain the emissions involved with the waste generated by MC manufacturing. And with regards to employee commute and business travel, so they also have data on total miles traveled by the employees using different transportation methods for their daily commute. So that's used to calculate their total annual emissions from their employee commuting. And if employees are working from home in a particular business, so the emissions from home working must also be included under employee commute as well. The UK government's conversion factor sheet has an emission factor for home working as well included. So that emission factor can be used to obtain the home working emissions. And similarly, MC Manufacturing have also used the business travel data to calculate the emissions from business travel of their employees using the emission factors from the UK government's conversion factor sheet. So using all the above discussed methods for scope 1, 2, and 3. So MC Manufacturing have calculated their total emissions across alpha as shown in the table. So they have a total emissions of 189.93 tons of carbon dioxide equivalent emitted for the year 2020 in their alpha unit. So since MC Manufacturing is going with the operational control approach, this will be the total emissions they are accounting for in their base year 2020. So I think the emissions calculation part is a bit complicated, but if you've got any questions, I should be able to answer them for you now.
No, I think you can carry on.
Okay. So if you've not got any questions, so the next step on our journey towards net zero is commitment and target setting. So, as discussed earlier, the Science Based Targets Initiative, also called SBTI, helps companies set ambitious and science based greenhouse gas emission reduction targets in line with the goals of the Paris Agreement. And with the amount of carbon budget left. So, science based target actually shows companies how much and how quickly they need to reduce their greenhouse gas emissions to prevent the worst effects of climate change. And SBTI illustrates how much companies need to reduce their emissions by using a linear annual emissions reduction. And this involves consistent gradual reduction in emissions over a specific period of time. And it helps to make the tracking of emissions and targets easier. And the benefits for a business is that it provides a predictable pathway, which is valuable for long term planning and budgeting. So, SBTI recommends two kinds of targets. The first one is the near term target, which is within 5 to 10 years. And if consistent with the goal of being net zero by 2050, an annual percentage reduction can be used. For example, every year the company will need to reduce its emissions by say 18% to be able to reach their near term and long term targets. So that is a near term target. And then next is the long term target. So long term targets are set for more than 10 years from the base year. So, a net zero by 2050 target will be considered a long term target, and they must have a greenhouse gas emission reduction greater than 90%, and the remaining percentage of emissions are to be neutralized using permanent carbon removal and storage methods. So, with regards to MC manufacturing, so MC manufacturing aim to be net zero by 2050. So, in that case, a linear reduction over 30 years is assumed for target setting from 2020. So, so if they consider 2025 to be their near term target, so that then says 6.33 tons of carbon dioxide equivalent multiplied by 5, so that's 31.65 tons of carbon dioxide, and it that results in a 16.66 percentage of reductions per year. So MC Manufacturing's near term target will therefore be a 16.66 percentage reduction in emissions compared to the base year, which is 2020. And if they reduce 16.66 percentage each year, they will then be able to achieve net zero by 2050. Any questions with regards to target setting?
Yes, we've got one coming through.
Yeah. So relating to previous section, what level of emissions calculation in terms of scopes are required by the government for the carbon reporting? So with the level of emissions calculation, it totally depends on the size of the company. So for large quoted or unquoted companies, they are required to produce an ACCR report every year. So the ACCR report requires a business to report on their scope 1, scope 2, and their employee commute from scope 3 as well. There's another requirement from the government, which is the carbon reduction plan. Many of the procurement processes involve submitting carbon reduction plans. So, with regards to carbon reduction plans, a business is supposed to report on scope 1, scope 2, and 5 categories of scope 3. So, the 5 categories of scope 3 would include upstream transportation and distribution, employee commute, business travel, waste generated in operations, and downstream transportation and distribution. So a company will have to report on all these categories if they require a carbon reduction plan. Apart from that, the government itself does not have any regulations on what level of reporting is required, but they recommend every business to report on their scope 1 and any applicable scope 3 categories in order to be able to achieve net zero by 2050. Any other questions? If you've not got any questions, so moving on to the next section. So, the next step, once the base year assessment is completed and the targets are set, is the development of an emission reduction plan. So, an emission reduction plan could be anything that helps the business to reduce their emissions and reach the net zero target. So, it could be anything like conducting energy audits, installation plans for energy efficient equipment, plans for conducting staff and supplier engagement events, etc. So, with regards to MC manufacturing, so they have planned to conduct an energy audit to see where most of your scope 1 and scope 2 emissions are from, and also conduct feasibility studies for installing solar panels on their roof. So, conducting an energy audit would definitely help a business see where most of their energy consumption is and then help them reduce most of their scope 1 and scope 2 emissions. So, this is conducting an energy audit is part of an emission reduction plan. Also, businesses, also MC manufacturing plans on having employee engagement activities to change their energy use behavior. So, this again is part of an energy reduction plan where a business can engage with their own employees in order to reduce their energy consumption within their business premises. And the next plan for MC manufacturing is to engage with their packaging material suppliers to purchase low carbon packaging boxes to pack their finished goods. So again, supplier engagement is another uh, is another factor that can be added to the energy reduction plan, which would help most of the businesses reduce their emissions from purchased goods and services, which would reduce their scope 3 emissions as well. So anything that comes under reduction of the emissions would fall under the emission reduction plan. And uh, so I think we've covered most of the sections that we are aiming for today. But as we move towards the end of the workshop, I would also like to briefly discuss on recalculation of base year. So companies may have questions on when do they have to calculate, or when do they have to recalculate their base year, and have doubts on when a base year recalculation is necessary. So just a few thoughts on when we'll have to calculate a base year. So, according to the greenhouse gas protocol, recalculation of base year is necessary when there are significant changes in the structure of the organization, or if there are significant changes in the calculation methodologies, where you try to use improved emission factors or improved quality of the activity data. So, that's when you will have to recalculate your base year emissions. And also, if you discover any significant errors in your base year emissions that you've calculated already. So all these things um, will force you to recalculate your base year, and it will also depend on the significance threshold. So all companies must define a recalculation policy where a significance threshold is defined. So significance threshold is a criterion that's used to determine whether a change is significant enough to warrant recalculation. And there is no specific significant threshold value, but mostly 5% is used. So if there is a significant change of 5% from the base year emissions with any changes that's happening within the company, then definitely a recalculation has to be done. And structural changes, as mentioned earlier, structural changes refer to transfer of ownership or control of emitting activities from one company to another. So these include mergers, acquisitions, divestments, outsourcing or insourcing of emitting activities. So these are the above changes that trigger recalculation if they are equal to the significance threshold. And some changes will not require recalculations according to the greenhouse gas protocol. Changes involving facilities that did not exist in the base year, outsourcing or insourcing of activities that were previously reported under a different scope, organic growth or decline. So, organic growth or decline refers to increases or decreases in production output, changes in product mix, and closures and openings of operating units that are owned or controlled by the company. So, for any kind of organic growth, a recalculation is not necessary, even if there is a significant increase in emissions. So these are the different factors that do not require recalculation as well. Uh, so any questions on emission reduction plan or recalculation of base year emissions?
No, doesn't look like it.
Okay. So if we've not got any questions, so that's the end of the workshop today. And thank you so much